Chapter 4, Section 3, second video. This one is about synthetic division. In math, typically almost in anything, you always end up learning the long way first so you understand what's going on, if you can, and then you end up getting shown the shortcut. Well, this is a shortcut. Now, it doesn't work for every long division, okay? But there is a shortcut for dividing polynomials by a binomial, a two-parter, okay? So this wouldn't work, for instance, if we look at our examples that we did in our last video. It would work for number 1, but it wouldn't work for number 2 because this is not a binomial, it's a trinomial, okay? So if it's being divided by a binomial, you can do what's called synthetic division, and it's a little bit of a shortcut, okay? So what we're doing is we're taking this bigger polynomial and we're dividing it by this guy. Well, the guy we're dividing it by is like x minus 3. And we've learned that when something like this binomial is in a parenthesis, if we had it set equal to 0, then x would equal 3. So we're basically evaluating this when x is 3. It's like we're plugging 3 into the equation and figuring out kind of what happens, sort of, okay? So what we're going to take is the 3. We're always going to opposite to get out of there. Now here's the setup. We've got the divide box, and then we have a working zone. And the working zone is built out of the coefficients from the dividend, okay? So as long as I got everybody, so we got 3, we got 2, we're missing 1, and we've got none. So I need 0x to the first. So I need to have a 0 placeholder. Same rule applies on synthetic division. You have to have everybody in place. But we're only going to take the coefficient parts, the part in front of how much x to the third, x squared, x, and stuff that we have. So we're going to take the -1. We're going to take the 4, and you can put positive if you want to. We're going to take 0, because we got to have that in there. We're going to take the 9. Now we have to separate our working zone from our answer zone. That's what this one is, okay? So our answer is going to go below here. Our work is going to happen, so this is where work happens here. And this is where the answer happens there. And we also have the remainder, if there is any. That happens here, okay? So I build this little setup. My 3 from right here goes in there. All the coefficients go in a line. You separate the very last one, the constant term, from everybody else. Past that line on the bottom is going to be a remainder. In front of that line to the left is going to be your answer. And we're going to add the exponents back afterwards. And it's going to be 1 degree less than we started because this is an x to the first. And if we take an x to the third and take off an x, what's left is x squared. Okay? So here's how this works. Bring the first number straight down. Then you're going to take this 3 and multiply it by the thing in the answer row and put it in the working zone. So 3 times -1 is -3. And then we're going to add down. So 4 and -3 makes +1. And we're going to take that 3 again and multiply it times that 1, and we're going to put it right underneath the next one. 0 plus 3 is +3. And then we're going to take that 3 and we're going to multiply it times that 3 and write it in the next one. 3 times 3 is 9. And so we get 9 plus 9 is 18. Now here's how the answer works. The x's you're going to use are 1 degree less than what you started with. We started with x to the third. So it's going to be -1x to the third plus 1x squared. Oh, sorry. Take that back. We were x to the third, now it's x squared. So negative 1x squared plus 1x plus 3 plus, and that's my remainder, 18 divided by what I was dividing by, x minus 3. And that's your answer. Now, you don't have to write the ones on there. If you wrote x squared plus x plus 3 plus 18 divided by x minus 3, that would be fine as well. You don't have to write the ones. Of course, that should be a negative x. Okay, make sure you carry the negative with it. You could even just write them in right there, and then you could throw the remainder on at the end. Whatever makes you happy, okay? So, let's try what happens whenever our binomial is a positive, right? So, I'm going to put our little work thing here. Opposite to come out gives me a negative 1. I got 3, I got 2, I got 1, I got none. They're all there. So 3, negative 2, positive 2, negative 5. Separate the last, separate the work from the answer. Drop the first one down. Negative 1 times 3 is negative 3. Add down makes negative 5. Negative 1 times 5 is 5. 2 plus 5 is 7. Negative 1 times 7 is negative 7. Negative 5 and negative 7 is negative 12. I was an x to the third, so an x squared, an x. So we've got 3x squared minus 5x plus 7 plus negative 12 over x plus 1. Or you could say minus 12 over x plus 1. Either is good. All kind of works. Okay? That's how it works. Here's a couple to practice on. Pause the video, try both, come back, see how they work. Okay, here we go. When I go over here, I do the opposite. It's going to be 2, 3, 2. See, I'll write them. 3, 2, 1, 0. Everybody's there. So to the first, negative 3, negative 7, and a 6. Separate, separate. Drop the 1. 2 times 1 is 2. Negative 3 and 2 is negative 1. 2 times negative 1 is negative 2. Negative 7 and negative 2 is negative 9. 2 times negative 9 is negative 18. 6 and negative 18 is negative 12. It was to the third, so squared x. So x squared minus x minus 9 plus negative 12 over x minus 2. Bringing it over to negative 3. 3, 2, 1, 0. I don't have any 2, so I got to put that 0 placeholder in there. So a 2, a 0, a negative 1, a negative 7. If you don't put the placeholder in, you get a very wrong answer. Drop the 2. Negative 3 times 2, negative 6. 0, negative 6 is negative 6. Negative 3 and negative 6 is positive 18. That makes negative 17. Negative 3 and negative 17 is going to be positive. 3 times 7 is 121, so 51. And 51 minus 7 would be 44. And it was x to the third, so x squared x. So 2x squared minus 6x minus 17 plus 44 over x plus 3. Did not go in nicely. X plus 3 was not a factor. Okay. And we'll explain that a little more starting now. The remainder theorem. Okay, a theorem is just a really good idea that they had that pretty much works all of the freaking time. We don't know that it's absolutely true, but every time we've done it so far, it's definitely working out. So, yeah, it's pretty darn good. So the remainder in the synthetic division process has an important interpretation. When you divide a polynomial called f of x, like Fred, by dx, like the dividing thing, right, like David, and then you get x minus k, the result is, right, so you're dividing by an x minus k, divided by a binomial. The result is all of this mathy junk, okay? And what they're saying is that because you're either going to get 0 or something, then whatever your remainder is, that's the value if you would have plugged in that k value into the equation and solved for it. Okay? So if I was to take something when I had, I'll draw it like this. If you have the parentheses around it, if I take the k, right, I opposite to get out, and I figure out what that number is. If I just plugged that into the equation for x and solved it, that's what I should get for the remainder. If it's 0, then y equals 0. If I plug in that x, then I get a y. If I get a 0, then it is a 0 of the function to solve a solution, an answer, an intercept. Okay, a 0. If I don't, it's whatever the value would have been had I plugged the x in. It's wherever up the graph goes or down the graph goes. So let's show you what I'm talking about. Okay, we can use synthetic division to evaluate this function, f of x equals 5x to the third minus x squared plus 13x plus 29 when x is negative 4. So what they've done is they've already given us what x is. They've opposited to get at. This is like saying x plus 4 in parentheses. Opposite to get out, x is negative 4. So when I put my little box, if it tells me x is something, it's already out. So I just plug in the negative 4. Okay. And then I've got 3, 2, 1, 0. Everybody's there. So 5, negative 1, 13, 29, separate, separate. Drop my 5. Negative 4 times 5 is negative 20. Makes negative 21. Negative 4 times negative 21 is going to be positive 84. That's getting huge. All right, so 13 and 84, 3 and 4 makes 7. 1 and 8 makes 9. Negative 4 times a negative. Let's see, I got to do it over here. 97 times 4 is 28. 36, 738 is 388. And so it's going to be negative, and I got to subtract 29, borrow, cheat, and steal. 18 minus 9 is 9. 7 minus 2 is 5. It's 359, negative 359. So this is the important part. We get, let's see, it was a third, so x squared, x, okay? We get this thing plus that divided by x plus 4, right? That's our thing. But this remainder of negative 359 is important because that's what the y is when you plug in the negative 4. F of x, technically f of negative 4, equals negative 359. So if we were graphing it, we'd go 1, 2, 3, 4 back, and we'd have to go up to negative, or no, sorry, not up. Wrong direction, because it's negative, right? We would have to go down all the way to make a dot at negative 4, negative 359. We figured out what it's worth. It's like if we had plugged it in. So if you take a calculator and you say 5 times negative 4, I'm plugging it in for x to the third, minus negative 4 squared, I'm going to move this over so I can see what I'm doing, plus 13 times negative 4 plus 29, what you should get, negative 359. So instead of, well, if you don't have the calculator with you, trying to do the negative 4 to the third times 5 and the negative 4 squared and subtract it and the negative 4 times 13 and add it and add the 29 and try to figure out that, you could do the synthetic division and figure out the value. Okay? So that's what you're going to do here. They give you a polynomial, they give you a function, it's called f both times, okay? They want you to figure out what happens when you plug in 5 for x, right? But they want you to do it using the synthetic division. So synthetically divide it, and I'll give you the hint. This is going to be x plus, or sorry, right? It already is a positive 5, so when we put it in parentheses, it's x minus 5, so opposite to get out is the 5, so it's going to be a 5 in there. This one's an x minus a 2. It's opposite to get out, it's a 2, so it's already a 2 in there. Set up the rest, get your coefficients in, divide your spaces, synthetically divide, find out what the remainder is. That's what we're looking for. Give it a pause and give it a try. Okay, here we go. 2, 1, none. Everybody's there. So 4, negative 10, negative 21. Separate, separate. Drop the 4. 4 times 5 is 20. 20 and negative 10 is 10. 5 and 10 makes 50. 50 and negative 21. Take 20 off is 30. Take 1 off is 29. So f of 5, when we plug in 5 for x, is 29. That's what we're looking for. All right, let's take this one. 4, 3, 2, 1, 0. We're missing the 2. I got to put in a placeholder. So 5, 2, 0, then negative 20, then negative 6. And separate. Drop the 5. 2 times 5 is 10. 2 and 10 is 12. 2 times 12 is 24. 0 and 24 is 24. 2 times 24 is 48. Minus 20 is 28. Not 280. What are you doing? It's 28. 2 times 28 is 56. Minus 6 is 50. So f of 2 equals 50 in this sense. I mean, the main thing we're looking for is the 50 and the 29, but that's how you would technically write the answer. You could also write y equals 50 or y equals 29. Either of those work. So you can use synthetic division instead of doing substitution and plugging the 5 in. You could synthetically divide. Okay? And that is